My name is Rick Viscomi. I'm coming in from New York. I work for a company called Scripps Networks. You probably recognize these brands: Food Network, Travel Channel. And so what I do is I work on web performance as my day job. And some people are fortunate enough to have like a quarter of their time to performance. I have 100% of my time on performance. So it lets me really like explore the different tools available, the different best practices. And one tool in particular that I focused on is web page test. When I'm not working on performance, I do some other open source projects in my free time. Truncate is one of them. It's an intelligent text truncation plugin to jQuery. Check it out. And also Red Dwarf, which is a heat map visualization of GitHub repository stars. If that sounds confusing, just check out the site. There's references at the end of the slides. And yes, judging by the picture, I am also a volunteer firefighter, so your fire exits are here and here. So this is web page test, and when we run a test, it's important to set it up for success early. It's easy to just click start test, and then you see a pretty chart, and ooh, wow, but it's really good to get things right the first time, before the test. And so you'll see number of tests to run, up to 10, and I chose 9. And this was actually a suggestion from Patrick Meehan, the maker of web page test, when that you pick a median, it's easier when you have an odd number of elements to get an exact middle value, as opposed to having 10 values, and then you have 2 middle ones and you take the best of the 2. And sometimes that's inconsistent. So one thing I learned directly from the horse's mouth is choose 9 tests. Also, you'll notice first and repeat view is checked off. That lets you know how well your caching is set up. And finally, it's hard to show on this, but highlighted in red is the video tab. And that gives you access to all the visual performance or perceived performance tools, like there's a film strip, video, and also something really cool called the speed index chart or visual progress chart. Very cool stuff. We're not going to go into perceived performance tonight, but what we will go over is a waterfall. So you run a test and you get something like this. It's very colorful, there's lots of lines, it's two-dimensional, so requests go down like that, time goes up like that, and we sort of look at this at first and say, okay, now what do we do? What are we looking for? Oh, well, I see at the top it says it took 15 seconds. Wow, great. But what does that 15 seconds mean? And how come when I run it in my browser it takes 3 seconds? So why is there this disparity between timings? And it turns out that time isn't really as important in this tool as you might think. It gives you timings, and sometimes it's easy to rely on time. Or, hey, look, our page is 6 seconds. But it's important to remember that web page test is a synthetic tool. It simulates a user accessing your page in a particular environment. In this case, it's like Dulles, Virginia, IE8 over cable connection or something like that. So it's representative of a thin sliver of your user base. You can check your analytics to see, I have browser users using a certain browser, certain location. You could simulate that pretty well here, but it's not representative of the whole population. Just keep that in mind. It's also prone to anomalies, so you run it once and you get certain results. Run it again. That's why we do 9 tests. It's supposed to smooth over these anomalies. So timing is a perfect example of how waterfalls can't accurately represent things like perceived performance. So sure, that image might load at that particular time, but when does the user actually see it, and in what order is it displayed on the page? These are things that the waterfall cannot show you, but we're going to see in a second that it does a lot for you. So there's one thing, I mentioned at first that this is requests and time. When we overlay, if you look at the left edge of all these requests, you can start to see a pattern emerge, what I call waterfall slope. You can see straight lines going down, that's really good, and horizontal lines going all the way out, that's pretty bad. That means in a long amount of time, you're doing very few requests. And what you really want to see is a very skinny chart, and you want to see things flow straight down as quickly as possible. You'll notice that there's a green line, a blue line. The blue line is the onload event, so if you have things happening after the onload event, that's fine, sure. If it's like, stuff like lazy loading, things like that, sure. If the user can't see it and if they're not going to know and it's not disturbing the user experience, fine, let's do that. But just keep it in mind that these things like slope and how many requests over time you can do is important. And this, looking at it from a high level like this, we can actually learn a lot about this page. And for anybody wondering, This is blogs.disney.com. And when I say Disney, yeah, I mean that Disney, the one worth $42 billion. So you think, maybe they'd have a different looking waterfall if they invested more money into web performance. So the waterfall anti-patterns are all around us. It looks like a mess, and it is, but by the end of tonight, you're gonna be able to spot each one of these. And you should have a pretty good understanding of these anti-patterns in general. And you might think to yourself, well, this is just their blog site, Disney.com is better, and it's not, it's even worse. If there's time later, I'll show you the difference, it's pretty bad. So we're gonna start at we looked at a very big view of a waterfall. Now let's look at the single unit, and it's a request. And I'll just go left to right, and I'm assuming everybody has seen this before, so I'll sort of breeze through it at first, and I'll give you my high-level analogy of a good way to remember how these things work. So at the left we have this padlock, and that's unique to this particular request because it's a secure request. Next is the resource number. In this case it's 2, so this is the second resource to be requested. A center truncated domain and resource name, so fbstatic.name, all that stuff, that's the domain name, followed by some CSS file. It's obviously been processed in some way because it's not legible. Next, it's kind of interesting to know this distance. This is what's called the start offset. The request actually is initiated at this point, but it takes all this time for that to start. So that's what's called the start offset. And now we finally get to the good stuff, the colored bars, and we start with DNS lookup. And DNS lookup is the resolution of example.com to some IP address somewhere. In this case, we're trying to translate Facebook to whatever its machine address is. Next is the initial connection, the orange. This is the TCP setup stage. This is how the user agent or the browser connects to the server. There's a few things that we can do to optimize this. This is like a opening connection type scenario, and we're going to see that there are ways that we can optimize all of these. In this pinkish purple, it's Ssl Negotiation, which corresponds to that padlock icon. Green is time to first byte. I use the acronym here because I feel like that's something we should just call it instead of time to first byte. It's a mouthful anyway. So TTFB is starting from the time the server receives the request to the time it spits out some information back to whoever made the request. And so sometimes that duration can be long or short, and that's a back-end issue. Back-end optimization is an interesting field. Web page tests can't really help us with that. We just see long green bars or short green bars, and we're sort of left to wonder, what's going on. So you need to combine web page tests with other tools. It's not a panacea. And finally, the blue bar is content download. So the server says, okay, I'm ready, here it goes, and it starts to deliver it. Whether it's long or short is more dependent on the network speed. If it's a fast connection, you can put more information through. And if it's a big document, it's going to take longer. So it's a combination of the two. So now my awesome analogy here is, the way to think about these things is almost like me traveling here from New York to Boston. So I knew that I needed to be in Boston for this talk, but I didn't exactly know the address. I'm just making this up. So I don't know the address. I just know that I have to be in this office. So I asked Jonathan. Jonathan may or may not know the address offhand. He should have worked here before. So maybe he doesn't know the address and he has to go ask somebody. This is sort of like the chain reaction in DNS lookups, which is one of the reasons why it's almost like the silent killer. And it's, you might get a little complacent and say, okay, well in my waterfall it's for 40 milliseconds, let's say. But in a worst case scenario, it can take a really long time if these DNS caches don't have that domain name readily available. So that's one of the reasons why it's really important to remember, minimize DNS lookups. Use the same domain for many requests. And you hear things like domain sharding, and that's one way to get more requests out, but you're incurring that DNS lookup, so just keep that in mind. So DNS can take a very long time in this chain reaction, so the way to optimize this is to ensure that your domain name stays in cache for a while, and that's the TTL, the time to live of the domain. So in my analogy, I come to Boston, I have to ask for the address and so on. Why don't I just write the address down, so next time I have to come here, it's readily available. So that's a caching. This initial connection, so I have to travel from New York to Boston. We all see how that worked out. It's not as fast as we would like. So maybe I should just sleep over next time and spend the night or something. Reuse the connection so I don't have to go back and forth, back and forth. This is done pretty easily, like a one-liner on the server side with keep alive. Very easy, and it saves a lot of time. Ssl Negotiation, I didn't have to go through security, but imagine in the lobby if there was some like metal detector or something, and I had to get authenticated in some way. The only way around that is just turn it off, take down security, and we can all imagine downsides of that. So for Facebook, security might be important because privacy is important to them. If you're loading, in my case, a picture of beef stew, that does not need to be secure. So just keep in mind the two different sides of the coin here. Time to first byte. So, oops, I skipped that. Time to first byte is, I'm here, I'm authenticated, and I'm fumbling around connecting my laptop. I know that I have to start giving a presentation, but I'm not ready to give it yet. So this is like server processing time in the back end. An optimization could be to be better prepared, practice more often, or in the real case scenario, do some database optimization, code tuning, just make it as fast as possible. Content download is when I finally deliver my presentation. Right now we're probably maybe about here, but we're getting there. So an optimization to this, keep it short, keep it simple. I can't speed up the presentation time, it might just get lost on you, but another optimization is if I do a good enough job, then you'll all retain this information, and that's client-side caching. I don't have to do the presentation again if you all forget. So you'll notice caching comes up a lot. So there's one really awesome saying in web performance, which is the fastest request is the one you don't have to make in the first place. So if the client has whatever it needs to put together a page, let it use it. No need to request it again. You might have also noticed this number 1247 milliseconds at the end. This is the total time from here to here. And as obvious, as it should be obvious here, everything should be as small as possible. The total request time takes over a second to load a CSS file. Is that acceptable? Maybe, maybe not. Make sure everything's as small as possible. Do what you can to reduce DNS lookup time and everything. You have more control over the green and the blue than you do everything else, but just keep it in mind. Also, some colors might be missing. If you don't use HTTPS, you won't see this purple in padlock business. If you enable keep alive, you won't have that nice orange. And if you use the same domain for another request, you won't see the teal. But sometimes, not only are these colors missing, they could also be separated, which kind of looks jarring at first. You might see the teal and the orange separated from the green and blue. And that's sort of like a new optimization in browsers where they can do this DNS look-ahead parsing.
Yeah, prefetch.
Yeah, it's a prefetch of the DNS. That's, Chrome especially does that. We might see that in one of the next slides. And you can actually instruct the browser in like the HTTP, not the HTML head. These are the domains I anticipate to use, and it'll go ahead and fetch them for you, which is nice. Okay, so moving on. We looked at requests, and now we're going to look at responses. For every request, there's a response. Sometimes they're in the affirmative, sometimes they're in the negative. In this case, we're seeing some yellow business. 302s and 301s. These are the HTTP status codes here. They're not always exactly the status code. You might see something like 99 or 9999. That's a web page test status code. In this case, because of the yellow color, we know it has to do with caching. 301 moved permanently, 302 found. When we talk about caching, it's good for the client to know that it can keep something in cache. But for the client to say, should I use this? Should I do something else? In this case, this is relocation of files. We'll see 304s later on, but it's kind of interesting that redirects and caching share the same color. It might get confusing. I got a little confused for a second. Redirects delay the loading of the actual content. So what's interesting is that in this test, we're loading Facebook.com. Facebook.com says, no, you want HTTPS Facebook.com. And HTTPS Facebook.com says, no, you want HTTPS www.facebook.com. So the actual the request does not start until 2 seconds. Does Facebook want that? Maybe, but they need to ensure that everybody's using a consistent starting point. And this is the cost you have to pay. Where possible, minimize this stuff. And it's in yellow for a reason, so it catches your eye. If you can, like if you have a link on your site, hey, check out the Facebook homepage and it's facebook.com. You're going to incur that redirect for everybody who clicks that link. So, just jump to step 3. No need to start at step 1. Next is this conditional get request. This is 304. And this is everything in these slides are real life stuff. And I get this from trolling the public web page test logs, and it's very, very exciting. So we're going to see a bunch of images coming through here now, and they take 260 milliseconds, which is pretty good. But there's so many of them that there's this blocking or stair-step pattern as they go down. And this is specific to repeat views. In a first view, you're never going to see caching stuff, because web page test is very good at clearing all the caches at first. But on this repeat view, you're going to see this. And one thing to remember is that browsers, even if you don't explicitly set caching headers, a browser will sort of connect the dots. It says, well, I know that this file was last modified a year ago and probably hasn't been modified since then, so I'll just use it in cache. And it makes a lot of assumptions, and web page test doesn't account for those assumptions because it can't tell the browser, well, you actually can configure synthetically which browser should or should not use that caching technique. So just keep in mind that although you might see some of these resources missing from the repeat view, they may still be set without good caching headers. Note that we're missing that blue content download part. So the server is doing some processing. Oh yeah, you can keep that, and it just sends a 304 response back, and there's no download, which is good. It's good not to download anything, but why do we need to check if all of these images are still valid? With the version in cache, is that still valid? Why don't we just set the appropriate caching header so it knows it's valid, as opposed to guessing or having to ask? A good rule of thumb is 1 year for static content, 1 year time to live, or TTL. And if you have to change it, just use cache busting. I think I have more stuff here. There we go. There's an example of 1 year TTL. Max age. Remember that number. It'll be on the test afterwards. That's the number of seconds in a year. Cache busting. So everybody know what cache busting is? It's a term for what you all probably already know. It's like appending a query string or something, or changing the file name, so that although you might have a very similar file, if you tweak some syntax or something, you need to invalidate what is in the user's cache and have them download it all over again. But it might have the same exact file name, so you just have to change a few things in either the query string parameter or the file name itself. There we go. So these are other types of responses, 304s. Not a lot has to be said here. Although extra credit, what happened here? Looking at the resource names, menu 2, menu 3, menu 4, undefined, undefined, undefined. Anybody have any ideas how this could have happened? Where does undefined come from in our programming day-to-day? It's a JavaScript value, right? So what if they were iterating in a loop, and then it ran off the end of the array or something, and then they started getting undefined? I don't know. This is what I found on the internet. I didn't make this up. So, yeah, it's just funny. Kind of want to shake people when you see this. Canceled request. This confused me for a very long time. I'm assuming some of you have seen this and just said, I don't know, and moved on. So, a canceled request has to do with the speculative loader, or the look-ahead pre-parser in Internet Explorer only. What you see is the recommended order of meta tag, space tag, and everything else. Meta tag, base tag, everything else. Microsoft suggests that if you're going to use these things, put it in this order. The base tag, I never knew about that until I started researching this thing. Apparently, like, change, if you just put like / index.html, it's assuming the base of that URL is whatever domain you're on right now. You could say, no, base is example2.com, and then everything else using a relative URL will be example2.com / index.html. Kind of interesting. Awesome. Okay. So why would you want to use meta HTTP equivalent? It's basically saying this meta tag is the equivalent of the HTTP header, user agent compatible or character set. Just put it in the headers, HTTP response headers. Microsoft said so do it. And there is a link right here. I'll share the slides later. Click this link. It's a very good read about why all this happens and how speculative loading works. Pretty interesting. So it's the regular parsing in sequential order, and then there's this thing that jumps ahead and says, okay, you're going to need this resource and that resource. But all of a sudden, if it goes ahead of itself, and all of a sudden it sees, oh, you wanted this in UTF-8. Crap, I can't use that resource. So it has to start all over again and cancel whatever request that it originally made. So if you use the HTTP header in the first place, when the document first starts loading and they have this pre-parsing, it's going to know ahead of time, okay, this is for IE7 and UTF-8, and everything I download from now on is going to be in the right character set and everything. So you won't have these cancel requests, and you're going to end up with a resource a second and a half sooner, which is pretty good. It looks harmless when you see that, it's just a glitch or an anomaly. It's actually your problem, and that's something you can fix pretty easily. This is fun. So we have a really big purple block. What does that mean? I'll state this outright, that these two have these asterisks here because they're Chrome and Firefox only. This has to do with the navigation timing API, which for some reason Internet Explorer 9 should have, but the APIs are working with web page tests, so you're not going to see it, at least as of now. This purple block, DOM content loaded, this is equivalent to the document.ready event handler that we're all used to hooking into. In this case, it starts before the start render. The start render is the first pane. So everything is blank on the page during this entire purple block. And how long is that? 1.6 seconds. So that's 1.6 seconds of JavaScript execution, let's just say. And the user is like just twiddling their thumb. So why don't we try to aim for the green line before the purple so that we get something on the screen so they can start interacting or reading the page, and then we can start doing all this JavaScript business. Or maybe we just want to minimize the JavaScript in the first place. So the order of these things is really important. Load event, that's equivalent to the onload. That's also your JavaScript event handling. Minimize that, keep it as small as possible. And finally, document complete is the load event start. That's when the load event has finally been fired. There's lots of load and other things like that. The easiest way to think about this is looking at this. And if anybody has looked at the navigation timing API, they've come across this. And I saw this and I was like, okay, well, how does web page test fit into this chart? So what I did was I got in touch with my inner Photoshop skills and I started taking away pieces that don't really apply. So DNS, that's the DNS lookup of the very first request. There's DNS all over the place with every single request, but only the first one is what we're talking about here, DNS and TCP connection. And so now we're going to start coloring it in, and we get this. So that looks familiar. We have the pink or the purplish, green line, the blue line, and the load. It turns out that light blue bar is fired immediately before the blue line. What I mean by that is your code could execute for any amount of time, but that blue line or that load event is always going to be fired immediately after you start your event handler. So, and I had to clarify this with Patrick because this kind of confused me. He said, so if you have a really long load event handler, it's going to be cut in half by that blue line. So just try to picture that. It's kind of weird. Start render, that green line, is not defined by any particular event. It just sort of floats around in the middle of this processing. And that's because it's a perceived performance thing. You can't really tell from the waterfall where that green line should be. You can tell where that blue line should be, but it's sort of ambiguous. So that's where perceived performance tools like the video and the speed indexing come into play. Very cool. So now we're going to move away from this low level and start working our way back up. And we're going to look at other patterns that have to do with many, many requests, one after another. So this is serialization. And at a glance, it might look like it's one at a time, but it's actually not. So you have an overlap here, and it kind of overlaps with this one. But if you look even closer, you'll see that the first one and the 1, 3 after that sort of line up. The end of that is the start of that. So you might say, okay, so this browser lets you have 3 concurrent requests at any given time, which is kind of weird, right? You never heard about a browser that does that. So it turns out above this, there's some really long image that's loading, and I just happen to find this pattern and load it. So it might take 4 connections at a time. Many requests, few connections. And you end up with, here's that slope line, remember? And it pushes it out. We want to do everything that we can to make that line straight up and down. So this pushes it out. So even though you're going to have 155 milliseconds per resource, which is pretty good, especially on a CDN, could be better, but that's still, it's not like all, how many of these? 12? I didn't write it down. I don't know, there's a lot of them. It's not like it's 152 milliseconds and then you're done. It's times, I don't know, math. So it's going to take maybe like 1.5 seconds or 10 times as long. So now's a good time to talk about HTTP 2.0. Because the traditional fix for this kind of thing is to just split up the requests on multiple domains. Although if these are images, you can combine them into sprites and things like that. But we're going to assume that these aren't things that can be combined. I left the resource types out, so we just sort of think conceptually now. So, okay, maybe we want to shard the domains and start trying to parallelize these things. But with HTTP 2.0, that's almost like an anti-pattern. So with HTTP 2.0 or Speedy, they use pipeline. So you just say, I want that, 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 and that. And the server says, okay, here it is, here. And what you end up with is multiple domains all incurring that DNS lookup time. And in the end, you might not even get any benefit from that kind of pattern. So it's almost like we're playing 2 different games at the same time. You're doing old school and new school at the same time. Optimizing for one or the other at the same time is kind of hard and tricky. So keep it in mind. Next, I'm going to preface the next slide that it's the same exact thing that you're looking at here. We're still looking at request serialization, but a sort of sibling chart to the waterfall chart is the connection view. And there's more colors here to memorize, but it's okay because there's a key. So this is bases.com, as we finally see, and 4, 5, 6, 7, 8, 9. So there are 6 connections that can be open at any given time, and the connections are being reused. At first we say, hooray, the connections are being reused. But then we say, oh no, because it's taking so long. And then we see this sort of segmentation of colors. We see CSS followed by JavaScript, followed by images, followed by some Flash scattered in there. You may say domain sharding, so all the images are on some other domain, and then you'll see this sort of stacking effect, where you can have 6 CSS and JavaScript, and maybe with Flash in particular, and 6 more images all loaded at the same time. Hooray, so that's good. It's the same exact pattern, but just a different view. So when you're dealing with how many connections do I have open, am I using my connections correctly, this view is actually better than the waterfall chart. And the good news is that they're right next to each other. Very, very cool. Next is more request serialization. Oh, yeah. My hand waving was moved into its own slide. Closed connections. So the thing to note here is that that orange, the initial connection, is being incurred for every single time. Might not be a big deal, but when you look at the proportions of colors here, that orange takes up like 1/3 of the time. So 30 to 50% of the time is taken by TCP overhead. If you enable keep alives, it'll be that much faster. Isn't that kind of weird? So instead of taking 300 or 200 milliseconds, it's going to take 150 or less. So these are the 2 views right next to each other. We have the waterfall chart on the left and a connection view on the right. And what's cool is that when you have this type of pattern, they're almost identical. And that's bad, because that means for every single request, there's a new connection. And you'll see it shows that orange in its own skinny little box. It's good to use both these things at the same time and get familiar with them. Network silence. So you make a request and then nothing happens for a while. And this is, I have to admit, this is one thing that I did not find in the wild. I had to make this up because it's kind of hard to exacerbate the issue. So I'm introducing these 2 other things here, CPU utilization and bandwidth utilization. I don't know why we don't use utilization. So CPU goes up, bandwidth never goes up, and it's just sort of down and staying steady. And 5 seconds later, we get a response back. Or 5 seconds later, we make a request. So, does anybody have any ideas why? And I'm not going to give it away this time. Yes.
JS.
JS? What do you mean JS?
Well, if it's doing some kind of processing, it's not going to do another thing.
So JavaScript blocks the thread, like say, a single-threaded browser. So if the JavaScript is busy, you can't make these requests. Anybody have any other guesses? That's one of the two that I can think of.
It's not just parsing the HTML.
Yeah, right. If there's something like expensive DOM layouts, I don't know, if you have like a table that, this is the one example I can think of. If you have a table that's dynamically flowing, as in like a 100% table or something, and it fills in lots of content dynamically, and you have to reshift as you add cells to it, the browser's like, crap, now I have to size it, and it's like, not very happy. So don't use tables, number one, and number two, learn to recognize, okay, I have a big gap. But keep in mind, that gap can only be caused by things earlier in the waterfall. So start looking, in this case, it's very easy. We have request 1 is the only one before that gap. So we know to look for that problem in our HTML file. I made a demo of this. And let's see how well it works. If I can find my cursor. There it is. That's really annoying. I think this will work. Yay. So I have my page speed on my site. So this is, it's working now. This is what it's doing. And then finally, my company will work. So the really interesting part is how I had to hack it to do this. And this is the fun part. It's looking at the source code. I have a while loop that pushes to some arbitrary array in the head. And you're going to look at this, I hope you're cringing at these like worst practices at work here. A document.write that writes an image in. And the reason why I did that was because Chrome, in my case, uses this look ahead. And it'll say, oh, I know you're busy in that while loop, but I see it's almost like that, what is it, like the exhibit with like, yo dog, I heard you like images, so while you were in your while loop, I loaded your image or something. So like, you have to really like break down to these worst practices to get here, but the scary thing is that you do that by accident sometimes. You might look at your waterfall and see a gap, and like, holy crap, if I have to do that to exacerbate the issue, what am I doing in reality? So yeah, that's really scary. I think that's the end of, oh, yeah, it's getting to the end. So the summary of what we talked about here, I want to return to full screen. We talked about waterfall slope. In your head, just sort of picture that red line flowing down the side and aim for that straight vertical line. We talked about the components of a request, all the way from DNS to content download. HTTP responses, we can have redirects, the 301s, 302s, caching, 304s, or the conditional get and the 404 errors. You can also get the other 400s in there, but 404 is the most common. Page load events and the navigation timing API. We talked about request concurrency and network utilization. And with that, thank you. I'm going to plug, I'm speaking at Velocity this summer, and if anybody here is lucky enough to get that free ticket, you can come see me. Sergey Chernishev and Annie Davies of Sergey's of the New York Web Performance Group. We're going to be giving a talk on a hands-on web performance optimization workshop, or WPO workshop. And that's June 18th in Santa Clara. So with that, thank you. I appreciate your time. Is anybody interested in seeing what I call the worst of web page tests? This is like 3 very brief slides of, through all that trolling of web page tests, I found some really, really bad stuff. And let's all laugh at that. Yeah, do you want to laugh at that? Okay. So this is 46 requests and only 5 were successful. The rest are 404s. FADAF, that's almost the worst, and no CDN. I'm not giving these people any anonymity, so applia.com, shame on you. 21 seconds to start render, 30% possible gzip savings. That's pretty bad. And you can see it's mostly this green bar, back-end time, that's where it is. Next, coder143.com, I have no idea how I came across this. not so bad. Hey, FAABC, and they use the CDN. There's 443 requests, 8,000 DOM elements, 1.6 megs of JavaScript. I can't even write that much. And it's getting cut off 75 unique domains. I can't even name 75%. So that's where this comes from. And what's cool is that when you look at it at this really like top level bird's eye view, you can see where the problems are. You can see this like steep, oh, not so steep anymore, not so steep, it's steep, but there's like long blue bars. And that's sort of my eye gravitates to long blue bars, and that's like really big stuff. That's probably all JavaScript. That's where that 1.6 megs comes from. You can even see the purple. It's like seeing the Great Wall of China from space. It's like, you can see a purple line in there, like, oh crap, I'm using a secure connection for casserole or something. And it gets worse. The worst possible web page test score, Fs and an X. TaberAdelaide.edu. This is a school in Australia. 2 megabyte page weight. Not as bad as before. I think combined everything was even worse. 26-second load time, 17-second repeat view. That's frightening. You know, when you have a repeat view, and if web page test is forgiving, they'll sort of like show you, okay, well, you probably intended to have that cache, so I'm going to cache that for you. 17 seconds, even with that, that's pretty bad. Now, what scares me is that when you look at this and you look at that, and somebody asks you which one is worse, you could probably say that one's worse. There's 443 requests, 8,000 downloads. Oh yeah, that's worse. But web page test tells you that's worse. So take with a grain of salt the scores on top. Just keep in mind that it takes very little to trigger one of these bad scores. And luckily, they're kind of easy to correct. See, you know, all these oranges. You turn on one line of code, keep alive on, you'll get an A for first quite time. Oh no, sorry, keep alive enabled. So that's all I got, and there's my closing slide again. So feel free to clap again. Thank you again. I'll take any questions, or I'll revisit any slides. Yes?
You started to mention Speedy.
Yes.
Could you dig in a bit and explain what happens in Speedy that's different from the multiple connections that we're used to today?
Sure. So the concept is called pipelining in Speedy. And Speedy's almost just like, hey guys, it's from Google, by the way. Hey everybody, like, let's try to do this instead. And then it's trying to influence this HTTP 2.0 spec. So pipelining is a different way of a server responding to requests. It sort of like queues everything up, and it says, it's almost like a batch processing instead of like a one-by-one. And the downside to that is you give me 100 things to do, I might be like shooting through all of them, and all of a sudden I get caught up on some back-end processing. Maybe I get caught in the database or something, and then everything else after that is halted, and it has to wait for me to finish up in the database. So there's a little bit of a hazard of using that pipelining thing. I believe they're trying to address this, but it's good in the way that you can give it as many requests as you want. You're not limited to 6 connections, but there is a hazard behind it too.
So I may be wrong on this. I'm thinking Speedy is actually one socket connection, bi-directional.
Right, there's one connection.
Everything goes.
Yeah, it's all over that same connection.
Yeah. And also, what about encryption? Is it always HTTPS? Is it always encrypted? What
With Speedy, yes it is. I don't think that's going to be a requirement for HTTP 2.0.
It probably will be, right? Because the reason it's encrypted is because you have all these HTTP, proxies and routers and stuff that try to muck with it and don't understand Speedy anyway. It's going to be forever until everything understands HTTP 2.0. So
Yeah.
I suspect that won't change.
Yeah. If it works for Speedy, it'll probably work for HTTP too. I think that's a really good point that you bring up security and secure requests, because I sort of joked earlier about having to load beef stew securely. Like, who cares? It's beef stew. But think about the effect of that. If it takes 700 milliseconds, hey, it's 700. But in the grand scheme, that might slow things down as it speeds other things up. So there is a certain trade-off there.
Well, isn't there a movement now that says everything should be HTTPS all the time?
Definitely. There is, yeah.
What do you think of that for performance? Or is the offset security and you don't care about performance?
Yeah, it makes people feel good that there's security involved. You know, you're only as secure as your weakest link. So if over the network is your weakest link, then yeah, you're boosting security. But if you write your passwords down next to your computer, you know, somebody's going to access your server and get all your stuff anyway. So security is good. I think if it was baked into the protocol in the first place, nobody would care. Nobody would say, no, I don't want this. Let's turn it off and make it faster. They'd just be happy with it and move on. So I think people are just sort of adjusting to it, and I think it is a good thing. And security is an important part of web networking in general. Yeah. Anything else? Yes.
Can you talk about the speed index that our web page test
Sure.
gives you? Because I think that's a useful number. And it's
Yeah.
kind of hard to understand.
I hope this is a link to the results. Yes, it is. Now I'm hoping this did not have. So I'm trying to find the speed index. Remember, it only works when you have video enabled. So now I need to find a test result that enabled video. And as you might guess, most of the people who have really, really bad websites might not know to turn this thing on. I think there's a click on this. If this doesn't work, I'll just load up a generic. No, let's just do this. It's freestyle. Test history. And this is good. This is how you find, this is how you troll the public logs. Show tests from all users. Although it looks like it's coming by default. That's how I do it.
There's a box for tests that have video.
Very good. Most of them are coming back with it. Be very careful. There's a lot of porn in here. Not safe for work. When I'm going through these links, I'm like looking for really slow websites, and I'm like, oh, that one's got to be slow. I'm like, oh! So be very careful. HP.com. No, that's not porn. Which is kind of interesting, and nobody ever talks about porn sites and web performance. They're supposed to be like, they're serving tons of video content and stuff. I want to hear from those guys what they do to make their websites fast. I think that would be an interesting use case. So this is speed index, and it's sort of like graphed, or actually speed index is just a number really, but this is what I was referring to, visual progress. The speed index is the like inverse of the area under the, I don't know, you got to know calculus to do it, but when you have nothing painted on the screen for 1.8 seconds, this is showing you, oh, I finally got something at 2 seconds. So you can scroll up and confirm that. At 2 seconds, about that time, now we finally have content being painted. So the speed index is a way of quantifying the visual progress of a site. And you can actually compare the way that 2 pages load a site by their speed index. And the one catch here is that it's only above the fold. It might be interesting to see, well, above the fold content, and this is true of all visual stuff, it's only above the fold. It might be interesting to see, okay, well, yeah, my gigantic banner graphic loads as the very first thing, and I get a very good speed index, but what about the article I'm trying to have users read below that? So it's kind of misleading in a way, but it's constant or consistent for everybody else. So visual progress I tie very closely with speed index, and it's pretty cool to see, wait, I was taking things away at 2.3 seconds? Like, it's kind of interesting to see it visually. And what's really cool is when you start layering different, actually, let's do that. What you can do is check off a bunch of things with video and compare them. And this talk wasn't supposed to get into perceived performance or the visual tools. Oh, man, fantastic. But this is one of the coolest features of web page test. So you can get them side by side. Film script, you can create a video and show that for your boss to say, make our site faster. This is bullshit. Google Charts is now computing, probably for a very slow page. See how long it actually takes. 5, 8, 10, 12 seconds. Of course, the one I pick doesn't have, what was the median? See if it helps. Maybe it isn't. But, yeah. Oh, well, you'll just see two different colors next to each other. And it's kind of interesting to see, oh, even if it's on the same page and you just tweak something, it's a really reassuring way to tell that your change actually improved performance by visually seeing, okay, I'm getting things loaded this way. Otherwise, it isn't working. But try this at home, it's fun. Test history, show tests from all users, or it'll be on by default all of a sudden. And just start clicking away at your own peril. Yay. Anything else? Yes?
So I think you said you set up your own web page test. How painful was that, and would you recommend doing
Very good question. I set up my own instance of web page test. It's like an open source project, so you can put it on your own VM or anything. It was relatively painless. I got it up in about a day. It helps if it's on like Windows 7 or something newer. It doesn't require a database, which is nice. It does require PHP. I think it's one of the newer versions, so that's a catch for you. What I found useful about that was being able to go behind network firewalls. When you have this internally, web page test can't hit your development environment, let's say. But if you have an internal version, you can test it. And it's sort of fun to see before and afters of how your development version is stacking up against your performance or your production version, and vice versa as you push something from dev to production, seeing what the changes, if any. Keep in mind that your servers that you're testing on are not the same as the public web page test instance, so there is going to be a little variability, but it's a pretty interesting way to compare. Good question. Yes?
One additional note about that, Hack does provide images for EC2 because you have to have basically agents to run the actual browsers and give you test results, and he provides images you can as well as EC2 pretty quickly. And it is fairly easy to set that portion of it at least. Instead of a couple of really small instances that run the browsers.
Yeah. Andy Davies, the guy who I'm going to be speaking at Velocity with, wrote a really, really good post about setting up a private instance all on your own. I think if you just Google web page test instance help, you'll get like his page as the first result. Very, very helpful. And just a quick plug for Sergey's thing, he made a product called Ssl, which runs web page tests over and over again. Over time, you could see, am I getting faster, am I getting slower? There's other synthetic monitoring tools out there, but I think that's one of the cooler ones. It shows you like your Y slow grade and your page speed score and things like that. Yes?
What are the other ways of looking at web pages other than web page test? Or what are the different ways of comparing? Because you want to compare different page loads for different tools, so what are the other options that are out there? So.
Good question. There are a few other, well, many other options. The first one that came to mind, I'm not sure why, is Yotta, Y-O-T-T-A. Probably there's another A in there. Does anybody know if there are two A's in it?
Yes.
Yeah, there is.
They're across the river in Cambridge.
Oh, okay, interesting. So they have like their own score, and they devise their score. It's probably out of 100, and they give you like an 86. So there are like that FFFFX. They sort of just quantify that in a number instead. And so that's one way of comparing web pages. It is subjective in a way, like how do you weigh one thing over another, and are you doing things that you have a perfectly good excuse to do this poor practice, but in the end it makes your web page faster. So like it doesn't really, it's not very forgiving, it's not very understanding when you do those things. What I really like about web page tests is that there's no excuse not to, gzip. There's no excuse not to have a fast time to first byte or all those things. What's awesome is that Pat chose like 6 really inexcusable metrics as its score. But as we saw in the worst of web page tests, it's not always indicative of really bad or really slow web pages. So keep it. But that is a good question. Web page test is not the only tool. Chrome DevTools is another cool one. There is a network view, and you can see all the same stuff with different colors in its own waterfall. It lets you save a HAR file or an HTTP archive file, and you can import it into tools that make it look like web page test, and many, many different cool tools available. But scope of web page test is Good enough for me, yes.
And one other option in that regard is, there's two things I know about it, like there's Torbit and LogNormal, which are both user monitoring entities, and basically you put a tag on your site, it makes the clients make a meeting request to their servers, then it shows you real user timing from the web timing API over a period of time. And you can do things like change your code and put different page groups and compare two page groups with different versions of the code base and compare the performance that way as well for real people. So it's another option.
What's the website?
LogNormal is got acquired by Ssl. So the car's coming out called Impulse.
Yeah. I got a preview of that, it's very, very cool.
Yeah.
Has anybody used Google Analytics real time?
Yeah.
It like, you can see a globe spin, or there's an option to see a globe spinning, and then it goes, oh, you just got a hit in London, and the globe spins, and like, I could just stare at that for hours. Imagine that on a big monitor in your office, and impressing people, and you can see like your median load time and real time, things like that. Impulse does that, and that's really cool. And it does, I venture to say, better run than Google does. Google measures on averages, and I'm not going to get into it mathematically why it's bad, but yeah, well, so with an average, if you have outliers, they skew the average. But when you take a median, you basically keep cutting things until you reach the middle value. And things aren't weighed or skewed one way or another. So with HS median, good. Google Analytics, average, bad. So
What was the name of that tool, sir?
Google
No,
Analytics.
the other one.
Web page test.
Impulse.
No.
Oh, Impulse, and that's at the SOSTA. And they are one of our sponsors.
Yeah. They recently became a sponsor as of like a few days ago, actually. So.
SOSTA, that's SOSTA. And the product's called letter N, Pulse. And this is what's really cool. LogNormal was acquired by SOSTA. Strangely was acquired by Radware. Web performance is a very good industry to be in, so we're all in the right place. Yeah, yeah. But after dynamics, I don't know who they are. Any other questions? Cool. Well, thank you all. I appreciate you coming out, and let's have more of that pizza.
Thanks. All right.